Welcome to my presentation on how image description systems describe people. Image description systems are systems that take an image as their input and that produce a natural language description of those images as their output. We'll be focusing on the labels in those descriptions that refer to people. First, we need to make a couple of distinctions. The first distinction is between evaluation and assessment. Evaluation can be defined as determining the extent to which system performance meets particular goals. Here you would ask, how well does my system perform? For assessment, this is defined as characterizing the performance of a system. So here you would ask, how does my system behave? The difference between these two is that the first makes reference to an external standard, whereas the second does not. For assessment, we just care about what the output looks like. Second distinction is between competence and performance, and this distinction is due to Chomsky. Performance is defined as linguistic behavior, and the question that belongs to performance here is, how does my model describe images? Competence is defined as knowledge of language. So here you would ask, to what extent does my model know how to describe an image? Now, many researchers are actually interested in competence. Competence is fairly hard to access because it refers to the internals of a system, whereas for performance, we only need to look at the output of a system. Some related or follow-up questions here are, what does it mean to be able to describe an image? And I think this relates to Mars' computational level. And also another question is, how should models even describe images? This relates to ethics and human-computer interaction. Now, in earlier work, we looked at how people describe other people. So we took existing corpora, the Flickr 30K corpus and the MS COCO dataset, and we looked at how people talk about other people. So what kind of semantic categories do they use? What kind of modifiers do they use? What properties do they refer to? And the steps that we took to identify all those categories are first looking at all the labels in MS COCO and Flickr 30K referring to people. So we took all the noun chunks ending with man, woman, boy, girl, male, female, and their plural forms. We manually categorized the label components. So if you have a label like the tall man, then the is a determiner. Tall is a modifier that refers to a person's height. So we categorize it as a height modifier. A man is the head noun in this case. At the same time, we built a context-free grammar that uses all those categories so that we could check the coverage of our categorization to make sure that we didn't miss anything. The result of this process is a domain-specific grammar and lexicon. And the lexicon you've seen on the previous slide, and the grammar looks a bit like this. So these are just rewriting rules to try to capture what a label looks like. In this paper, we're going to be characterizing system performance, which means that we will try to assess the extent to which systems generate different person descriptions. We're going to extend the existing grammar and lexicon to cover more head nouns and modifiers. And hopefully with enough input images in the test set, so we're going to be using the test set of the MS COCO corpus, which consists of thousands of images, we'll be able to approximate system competence. So all we have is system performance, but if the system fails to produce particular kinds of descriptions for so many images, then maybe these models are just not capable of ever producing these kinds of descriptions. Now, our approach consists of 3 stages. The first is extending the existing grammar and lexicon to cover other person nouns and modifiers. So I looked at the output of 9 different systems and made sure that the grammar and lexicon cover those outputs. Then the next step is to use the grammar to parse the system outputs and then to generate statistics about the use of different kinds of nouns and modifiers. Challenge here is that categorizing all nouns in the MS COCO and Flickr 30K dataset is way too much work, especially for a single annotator like me. Solution here is to just categorize all the nouns that are generated by existing systems. So for all those nouns, I looked at, does this noun refer to a person, yes or no? If yes, then I categorize them further. If no, then we can just discard them. The implication here is that for new systems, you would need to check whether it produces any nouns that are not in the lexicon yet, that do refer to people. I don't think this is a lot of work because current systems just don't really produce very diverse output. So I'd expect this to be maybe an afternoon's worth of work. Now for the results, I've identified 6 head noun categories. These are activity, things like baseball player, commuter, kite surfer, pedestrian. Age nouns, like adult, baby, child, toddler, so on. Gendered nouns like boy, girl, man, females, woman, etc. Plural or mass nouns like crowd, passengers, persons, business people, etc. Relation nouns like father, friend, patient, bride, daughter, etc. And status or occupation nouns like clown, coach, police officer, and so on. Another result is that we now have a parser that covers the output of 9 image description systems, and that probably covers most of the output of any other system. Here's an example parse tree that shows you what the output of the parser looks like. You can see that it correctly identifies the height of a person, the mood of a person, and the age noun at the end of the expression. The paper also contains a comparison of the 9 different systems that we looked at, but I don't have any time to discuss this table in full, so instead I have a couple of observations on the next slide. So the observations. The systems only use between 4 and 13 different modifier categories out of 40. That means that many categories are just not used by these systems. For example, only one system refers to someone's height in the expression a short young boy. The lack of variation, this idea is also supported by the fact that there's very little variation within each of the categories. So for example, in the build category, only 3 out of 48 modifiers. So only big, small, and tiny, but 45 other modifiers are just not to be found in the output. There's also evidence of bias in the output regarding gender and ethnicity. So for example, hair color is only specified for women. And for ethnicity, only Asian ethnicity is marked. So white and black, never mentioned by the system, but only Asian is mentioned by the system. Now, some limitations of our approach and some suggestions for future work. First, a warning. The grammar and lexicon are only meant for assessment purposes, not for training. So in theory, you could use our data to train a system to produce person descriptions. That's not our goal here. I don't think this is something you should do. And this is also the reason that I started this presentation by identifying the difference between assessment and evaluation. This paper is really geared towards assessment rather than evaluation. I don't think we're ready for evaluation yet. The lexicon has been developed by a single annotator, and it needs checking. So, well, I think the main conclusions of the paper are correct. For widespread use, I think someone else should also look at this. Now, for future work, there are 2 issues that I think are fairly easily solved, but that would that I think would make a difference. So first, our parser overgenerates. So it doesn't have any word sense disambiguation or anything like that built in. So we'll just generate parsers even though that category may actually not apply in this context. Second, the current lexicon has limited coverage. As I said, it only covers the outputs of those 9 systems plus all the categories that we've already identified in previous work. Now, I think both of these issues could maybe easily be overcome by using a language model, something like BERT. And the data that we have may relatively straightforwardly be converted into a training corpus that, with a bit of checking, could be used to train a sequence labeling model that can actually do a better job than our parser. So that's something that someone may want to work on in the future. For a conclusion, I think this work at least shows that it's feasible to characterize parts of the output domain for image description systems. So now we have a fairly full characterization of people descriptions in the Flickr 30K and MS Coco dataset. And so we know what possible descriptions could look like and also what systems tend to output. But we still need to have a discussion on what description should look like. And I think that discussion needs to include key stakeholders. So people who are blind, who have a visual impairment, are typically not included in NLP studies. They are included in human-computer interaction studies, but the fields are fairly disjoint. So there's people in human-computer interaction, people in computer vision, and people in NLP that all do work on the same problem, but that don't really talk to each other. I think that needs to change. And I think that discussion could be very fruitful, and that could lead to actual guidelines on what image description should look like. And once we have those guidelines in place, an assessment technique like the one I've presented in this paper could actually become an evaluation metric, because then we could check whether generated descriptions actually conform to the existing guidelines. But until then, it's just an assessment metric, a metric that tells us what the output. So with that, that's all I have to say. If you have any questions, please just contact me either via mail, via Twitter, or maybe virtually at the conference. But thank you very much for watching my presentation.